we're going through today 4G and 4C.
No Sims likes
and we'll
girls.
find them just a short extension on what we've done. And from 4C, there's only 2 questions you need to do. Okay, so we're going to get into both. Now this statement here is what we call the fundamental theorem of calculus. Now we're already familiar that if we integrate f of x, we're going to get some big function, some big f of x. So we're going to apply this formula here. Now one thing I do want to say is just a difference in notation. Alright, here I don't have a boundary, I don't have any numbers written here. So that's what we call an indefinite integral, because there's no constraints or restrictions. Here, this is a definite integral because it does have boundaries. It has constraints, it has restrictions imposed upon it. So we have indefinite and definite, okay? And let's process this definite integral, and we're going to see a key difference between the two. So the first thing we have to do, well we can do, is we can pull that 5 out the front, can't we? We could write it like this. Integral from 0 to 2 of x to the power of 3. And now we can perform that integral, right? We know if we integrate x to the 3, it becomes x to the 4 on top of 4. And we're integrating it from 0 to 2. Alright? So we've moved from this step in the fundamental theorem of calculus to this one. I've got my big function, and I've stated my boundaries here from 0 to 2. Alright? Now that 5 is still just going to hang out the front. And then what we have to do is f of b take f of a. So we've got to substitute the top one in and then subtract the bottom one in. So let's substitute 2 in, and then we're going to take away when we substitute 0 in. Alright, so we're going to have 5 times 2 to the power of 4 is 16, divided by 4 is 4. And this is going to be 0. We've got 5 times 4. Our answer is 20. Now I missed something out here, but I missed it out on purpose. What did I forget to do?
Plus C.
Plus C. So if I went plus C right, okay, when we go into this step here, I'm going to have plus C, and then over here I'm going to have take away plus C, and so I've got C take C, it cancels. Okay, so this is the key difference between a definite and an indefinite integral. When you have a boundary, a definite integral, you don't need to put plus C because it will cancel. Always. You only need plus C when you don't have a boundary, when you have an indefinite integral. Very good. Let's move on to the next one. Alright, integral of e to the 2x is going to be 1 on 2 e to the 2x. And we're integrating from 0 to ln 3. Okay, so that's step 1 of the fundamental theorem of calculus. Let's move on to step 2. We're going to perform the substitution. We're going to have half e to the 2 ln 3, take away half e to the 2 times 0. Now there is a temptation, and I've seen students in the past just go, oh that's 0. Alright, there's a 0 involved, it's 0. That's actually not true. We do have to be careful here and process that a bit. So let's process both using log laws and simplify as much as we can. This is ln 3 squared. Right, if we have that 2 out the front, we can make it a power. And this is e to the power of 0. 2 times 0 is 0. And ln 3 squared is e to the ln 9. And any number to the power of 0 is going to be 1. And then e to the ln x, okay, remember this, e to the ln x is x, so e to the ln 9 is going to be 9. We've got half times 9, take away half. So that's 9 on 2, take 1 on 2, it's 8 on 2, and 8 divided by 2 is 4. Alright, so we process that, and that's what we'll simplify to. Okay, so that's what you're going to be doing in G. Let's jump over to C. Alright, because here's where we really make the connection between what we've been doing. So, this is the fundamental theorem of calculus, right? But what does it mean? Alright, let's say we've got some function, some curve, and remember at the start of the unit, how we were doing and the area under the curve by using rectangles. Okay, we were doing an approximation of the actual area. Well, if we have some function, then the integral from a to b of that function, let's say here's a, here's b, that's going to be the area under the curve between a and b. Alright, so integration is about area under the curve, whereas calculus, if we recall, f dash of x, is about how steep is the curve. Okay, so that being the key difference between the two. Alright, so let's look at what we're doing in 4c then. We've got the first example there, and I've written it all out for you. It says find the area under the curve from x to the power of 3 from 1 to 3. So the boundary is from 1 to 3, and we always put the number closest to the left or furthest to the left at the bottom, and the number furthest to the right at the top. And the function we want to know the area under is x to the power of 3. And they've gone ahead and processed all of that one for you. It's either integral, and then they've performed the fundamental theorem of calculus and simplified. Okay? Let's do it for b. It says find the area under the curve 3x plus 2 from 0 to 5. So what does this mean? It means find the integral from 0 to 5 of the function 3x plus 2 with regards to x. Okay, how are we going to do that? We're going to integrate it. So the integral of 3x is going to be 3 on 2x squared. And then the integral of 2 is going to be plus 2x. And we're going from 0 to 5. Alright. Now let's perform the second step where we're going to substitute in a and b. So we're going to have 3 on 2, 5 squared, plus 2 times 5. Okay? That part there is f of b. That whole thing is the first part. And then I need to take away f of a. So I want you to be careful when you're doing this. Alright, you need to put the second part in brackets so that the negative can distribute. It's not going to have an effect this time because that all goes to 0, but it will in the future where it is a non-zero entity. Alright, so we know that that part's going to 0, so let's process this. We have 3 times 5 squared, that's 3 times 25, that's 75 on 2 plus 10, take a 0, and 95 on 2. Now, key difference here. In 4c, we're asked find the area, and we've performed an integral statement, so that means we need to answer in units squared. Right? When we're just asked to evaluate a definite integral, then we just leave it as a number because it has no context to it. Right? It's only if we're told find the area that we need to give it a unit squared. Okay, now in this exercise, there's a number of proofs that you're going to do. Question 5 is all about proofs, okay? And you're proving the properties of definite integrals. So we're going to do one together. And these proofs have popped up in the tests a fair bit. And they're good proofs because they're not too complex, and they really teach you about how to perform proofs. So it says, prove that the integral from a to b of k with regards to x is equal to k times b take a. Alright, wants us to prove that this is true. Yeah, let's get the camera over. K times b take a. Wants us to prove that's true. Now with a proof, this is how we go about it. What we need to show is that the left-hand side equals the right-hand side. So we need to manipulate one or the other or both until they're the same. That's all you have to do. That's what a proof is. So let's start with the left-hand side. I can't really change anything now. I mean, I can expand it and so forth. But here I can perform something because I can integrate. So I'm going to look here and go, yep, let's start here. We've got the integral from a to b of k with regards to x. Now, what is k but some number? K is a number, it's a constant. And so when we integrate it, we're going to have, when we integrate k, we get kx. And we're integrating from a to b. Okay, that's the first step of the fundamental theorem of calculus. Then we'll perform the substitution. What does it become? K times b take k times a. What is common? K. So we'll pull it out the front, and we're left with b take a, which is the right-hand side. And so we've demonstrated that you can start with the left-hand side, manipulate, and you get the right hand side. And thus the left hand side is equal to the right hand side. The proof has been demonstrated. Alright, so you get to prove all those properties that are listed in the green box, or for you guys the grey box, and I've got them listed in both C and G. So it's up to you where you start, if you start with 4C or if you start with 4G. In 4C, you're just doing question 4 and 5. Alright, so let's get into it.